Hey, happy Tuesday, everybody. We got a warm up for you, and it should help you with your homework today. So let's get on it. You know the drill. Copy this down. Go try these problems. Come back and get help if you need it, or check your answers. I want to remind you on this. This is this line. How long is this line? You're going to use an expression, x plus 1.8 plus x. But then when you're done, put the like terms together. Put all those x's together. There's another way of writing x plus x plus x plus, right? And you can put the 2/10 and the 1 8/10 together as well, okay? Do that. When you're done, pretend the line is 32 and solve for x, all right? You're going to have an algebraic equation at that point, okay? And don't forget, isolate the variable, right? You want to use inverse operations, right? All that kind of stuff. And then this is something that's new, so you might come back and watch me do the first one and then press pause and do the rest, all right? All right, we'll see you in a bit. All right, 36 and 12. What two numbers multiply together equal 36? Get a product 36 and a sum of 12. That's 6 and 6. That's a perfect square. 36 and 13. That's the product of two perfect squares, right? 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. 4 plus 9 is 13. All right, how about 28 thousandths and 74 hundredths? 7/10 and 4 hundredths, right? When I go to add those, remember how you stack them and line up the decimals, right? And the decimal's going to come straight down. It looks weird because one number comes out to more digits than the other. Past the decimal, I can add zeros, right? So I add those, I do get the 74 hundredths. When I multiply, I go 7 times 4 is 28, right? Pretend there's no decimal. But to pretend that there was no decimal here, I had to move the decimal over here one spot to make that a 7. Here I had to move it over 2 spots to make that a 4. So that's a total of 3 spots in my problem that I moved the decimal to the right. So in my answer, I got to move back 3 spots in my answer. And that's how I got the 28 thousandths. Okay, let's stump you on this next one. Those fractions and whole numbers and mixed numbers. 3 plus 1 1/3 is 4 1/3. And 3 times 1 1/3 is 3 ones. That's 3. And 3/3 is 3/3. 3/3 is 1 whole. So that equals 4. All right. All right, x plus x plus x plus x plus x. That's 5 of those babies, right? So let's just say 5x. That means 5 times x, right? X times 5 equals 5x. Now 1 8/10 and 0 2/10, when I add those, nice even fit, right? Those are compatible numbers. That becomes 2.0, which is the same as 2. So we're going to say my expression is 5x plus 2. Okay, that's my answer for the expression. Now, if I know that 5x plus 2 equals 32, and I write that, now I have an equation. Remember, an equation has an equal sign, and it says that everything on one side is in perfect balance with everything on the other. To solve an equation, you want to isolate the variable. That means you want the x, the variable, all by itself on one side, the equal sign, and that leaves space for a number on the other. You have an answer. Okay? Now, to get rid of that, I'm going to get rid of the plus 2 first. Now, I'm going to rewrite the 5x back like I had it originally, because eventually I'm going to want to get rid of that times 5. But first, I'm getting rid of the plus 2. What is the inverse operation or opposite of plus 2? It's minus 2. And if I do it to that side, I got to do it to this side. Same thing to both sides. I was doing another color ink so you can see nothing changed except for this. Okay. Now, plus 2 and minus 2, they cancel each other out. All that's left on this side is x times 5. All left on this side, 32 minus 2 is 30. Now, how do I get rid of it? Times 5. What's the inverse operation or opposite of times 5? Divided by 5. But that would get my equation out of balance unless I do the same exact thing to the other side. Now, 5 times and 5 divide. right? I make it 5 times bigger, then I divide it, make it 5 times smaller. I'm back where I started. That leaves with x on this side, 30 divided by 5. Then you say you're done, but then you say, but wait, aren't I supposed to do one more thing? Yes, you should. You should double check. Whenever you do an algebraic equation, you should go back and plug in your answer to your problem and see if it works. So if x equals 6, then I should be able to put an x in for 6 in for that x. Now that's not 56. That's 5 times x. So I'm going to have 5 times 6 plus 2 and see if that equals 32. Now 5 times 6 is 30. Is 30 plus 2 32? Of course it is. So you did it right. And then you double checked like you should. All right, calculate. How am I going to do this? There are different ways. Okay. Sometimes people like to use the C method on these and turn these into just improper fractions. 3 times 2 is 6 plus 1, 7. So 2 1/3 is the same as 7/3. 2 1/2, 2 times 1 is 2 plus 1, 3. This is 1 1/2 is the same as 3 halves. So I can multiply across the top, multiply across the bottom, and then realize 3 goes into the top and the bottom. And then divide the bottom into the top, right? And that goes 3 times because that's 6. My remainder goes on top, my divisor on the bottom. Now, another way of doing that would be to make a generic rectangle. Okay, so what if I had 2 1/3 and 1 1/2? Well, 1 times 2 is 2. 1/2 of 2 is 1. 1 times 1/3 is 1/3. 1/2 times 1/3 is 1 times 1 on top, 2 times 3 at the bottom, 1/6. So I have 3 here, and I have to add a third and a 6. 1/3 is how many 6? 1/6 is 1/6, right? So I have to change that to 2/6, and 2/6 and 1/6 is 3/6. So I have 3 and 3/6. 3/6 simplifies to 1/2. Same answer. Okay. Multiplying decimals, pretend there's no decimal. 7 times 1, 7 times 3. Placeholder, 2 times 1, 2 times 3. Add 837, but I moved it over once there. I had to go back twice. 8.37 is my answer. Now here you have the choice. Do you want to make this a decimal or this a fraction? All right. Well, either way, right, I'm going to go ahead and make this a decimal because I know that 3/4 is 0.75. So $2.75 is 2 3/4. Multiply here, 20. 28 and 2 is 30. 8 and 3 is 11. Placeholder, 25, carry the 2. 35 plus 2, 37. Carry the 3. 10 plus 3, 13. Now, I had a couple of decimals there, right? This was 5.4. I moved it over once. This was 2.75. Moved it over twice. That's 3 spots in my answer. I got to go back. 14.85. Now, what's another way of figuring out where my decimal should go? Estimate. This is about 5. This is about 3. 3 times 5 is 15. I have to put a decimal somewhere in this 1485. It only makes sense to put it there. If I put it here, my decimate's 15. I have something 1.4. Now, I put it here, 148. That's too big. So it only makes sense to put it there. Okay. All right. Distributive property. What does that mean? That means they want you to make this 2 easy problems instead of 1 hard problem. What's 2 easy problems? Well, 50 is the same as 50 plus 1. So I'm making this 6 times 50 plus 6 times 1. 6 times 50 is easy. 6 times 1 is easy. And 306 added is easy. Okay, distributive property. Then what do you want to do here? Some people say 20 and 6, but hey, I know how to count by 25s. Why? Because I love money. 25s. That's quarters, right? How many quarters is $8, right? So I'm saying this is the same as 8 times 25 plus, right? This is 25 plus 1, right? Plus 8 times 1. Now, don't just add the 1. Make sure the 8 has to go to each thing inside. The 6 had to go to each thing. Distribute. That's what it means. It's like you're dealing cards. You don't skip over someone. Give this card 8 and not give that card any, right? So 8 quarters is 200, right? And 8 1, so 208. Now, how about this one? This is kind of tricky. This one you're going to do, that is almost 50. 7 times 50 minus 1. Same idea, but I'm going to take this and subtract this product. So I have 7 times 50 minus 7 times 1. And 7 times 50 is easy. 7 times 1 is easy. And most of you do that in your head. Okay, pretty cool, huh? All right, now you know how to distribute. And I can't tell you now, but these three, if you stay with me till the end, they're on the homework tonight. All right, enjoy, you guys.